All right, ladies and gentlemen, this is going to be the next video on energy and life. So let's get started on this next video. So what is the energy currency for life? Well, the energy currency for life is adenosine triphosphate, and it's going to consist of a few parts. We're going to have the ribose, the adenine, and then our triphosphate grouping at the end. We call that triphosphate because of the three phosphates present on this molecule. Now, adenosine triphosphate is a chemical compound that's going to store energy in the body to be released later to do work. And we've already gone through and talked about it a little bit, but it's going to be crucial that we understand that ATP, or adenosine triphosphate, right now has three phosphates, and that is what is providing the energy for our body. So why is ATP useful to cells? Remember, energy is the ability to do work. So if we're thinking about this, let's say we were in a warehouse and we had a shelf and we had a forklift. Now we need to move these really, really heavy boxes up to the tops of these shelves. So we're going to take our forklift, we're going to go through and move the boxes up there. Now here's the thing. We're going to have to use fuel to get that forklift to work to put the boxes on the shelf. And this is what we have to understand here. Our body is going to require energy all the time, and specifically chemical energy that we've gone through and talked about. Your body requires chemical energy in order to go through and complete tasks, maybe like swimming or mountain biking or surfing. And without the energy from ATP in our body, we cannot go through and complete any of these tasks. So ATP is vital and crucial because it's the fuel or the main source of energy, chemical energy specifically, in our body. Now, the two molecules that are present when we're talking about energy are going to be for storing energy and for releasing energy. So when we're talking about short-term, really short-term storage of energy, we're talking about adenosine diphosphate. And adenosine diphosphate is going to be different from adenosine triphosphate because it's going to be missing one of the phosphate groups. In adenosine diphosphate, we have two phosphate groups, whereas in adenosine triphosphate, there are three phosphate groups. So one of the common misconceptions that people have is just the cell is full of all of these ATP molecules, and that's just not the case. So if we're thinking about this, ATP is not a good molecule for long-term energy storage. So if we're thinking about one glucose, a single molecule for the sugar glucose stores more than 90 times the energy required to add a phosphate group from ADP to ATP. So if we're thinking about this, the cell's going to regenerate ATP from ADP is needed. And one of the things that we have to understand here is plants are going to produce glucose, which is going to be converted into ATP. ATP is going to degenerate very, very quickly compared to other molecules. So it's more efficient for your body to store it in glucose or ADP. Now, one of the ways that we can kind of visualize ATP versus ADP is we can think about these flashlights. Now, if I have rechargeable flashlights and we have this first flashlight on the top, it only has a partial charge. It's almost empty. And the light generated from that flashlight is not going to be very bright. Now, the flashlight on the bottom, well, the charge is completely full on it. This is kind of like our ATP. We're going to get a really bright beam of light, and it's going to extend that beam really far out into the distance. So if we're thinking about this, ADP is kind of like that uncharged flashlight. The partially charged battery that stores the energy for that flashlight only has a small amount of energy. Whereas the charged battery in the flashlight is kind of like ATP. It has a fully charged battery, and it's going to have a lot more energy, and that energy can be used to create a larger beam of light. So really what our cell's going to do is it's going to get glucose, and that glucose gets sent to the mitochondria. And then within the mitochondria, what's going to form are all of these ATP molecules. But how are they going to release the energy necessary for this cell to use? Well, releasing energy takes place via the breaking of bonds. So what's going to occur is when you break a chemical bond, it's going to release energy. So what we call this is dephosphorylation. It's the removal of a phosphate group via an enzyme, and when we break that phosphate group, we release energy in the cell. So the way our body is getting energy is through this molecule, adenosine triphosphate. Now, all energy is not just inherently born within these cells. We have to get this energy from somewhere. And all of that energy is really going to come from sunlight. So the entire ecosystem is dependent upon the sun and the energy that we get from the photons from the sun. So photosynthesis is where the autotrophs go through and produce high energy carbohydrates and sugars and starches that will go through and be consumed by herbivores and then be consumed by carnivores. So a cell does not automatically have this ATP. So if you're a heterotroph, well, this is an organism that's going to have to get ATP from other organisms. So in the case of heterotrophs, this could be a carnivore going through and consuming meat, or this could be a herbivore going through and consuming plant material. Now, organisms that are going to make their own food are going to be called autotrophs. And autotrophs are generally going to get their energy from the sun. And they're going to take the sun and the photon energy from the sun and convert it into chemical energy. So all energy and life depends upon the sun and the ecosystem, and all life depends on all of the solar radiation that we are getting radiated down on Earth from the sun. So did you guys learn? Well, did you learn a couple of things? Did you learn what the energy currency for life is? Did you guys learn the difference between ATP and ADP? And did you guys learn the difference between heterotrophs and autotrophs? This is going to be the end of the video. I will see you guys in class tomorrow.